Hello everyone, welcome to my next tutorial of the Lois series parts. In this tutorial we will be study how two solar cells are connected in the series. So before we start off this tutorial I want to introduce myself as I am Sahil Verma, application engineer of the well-known company Impulse Technology. And we are going to simulate in here two cells that are connected in a series, and you can see the area of one cell correspond to 200 mm into 200 mm module with the 16 cells. So as well as the area that connect the two cells, the monolithical interconnection are called P1, P2 and P3. That means you can see P1, P2 and P3 as P1 tops and bottoms and P2 and P3 top and bottom. So we will be connect to that two solar cells, and then we will be simulates their properties in the large area organic semiconductor simulation tools. So it is developed by the Fluxim Ag. Who has not seen it, my previous video, please check out the playlist. We have already discussed about the Fluxim Ag and their products and our company features and their services. So we will directly simulate that series interconnected solar cells in the large softwares. So now I'm going to open that software. You can open from here. It is the GUI of the large software we have already discussed in a previous video, but at the soft description that I want to give you, like who has not seen it, so please check. File, new projects, load, import from zips. That means you can create from your new project. You can also load here from the projects if you are working or want to import from another one's projects, and export to zip and import geometry, as well as you can save from your projects if you have simulated any projects and exit. At the same time you can see in the click of the new project large area 3D rotations. You need to give in the project name, project files, project directly. So give in the new names series interconnected solar cell, and then you can click on the OK and click on the properties manager tabs. You can see the project path. You can see near the geometry input types. We have already discussed in a previous video, but one by one we can also explain in here. DSF geometry files, if you choose, you need to import that formats files that support the DSF. UNV files, predefined geometry as a rectangles. You can create in your own geometry. Metal fingers, like if you click on this show geometry, you can see. And metal strips, show geometry, you can see. If you increases the number of the metal strips, you can see. So width or height you can give in here, and you can change as per that value, like 10, and click on this. So you can create in here the own geometry, as well as you can see in here the defect. If you want to create in here the defect, you can see two meshing tools are given. You can create in here the meshing and you can run that meshing. If you want to divide that geometry or small parts, so you can give in here the minimalist size and maximalist number of the vertex, number of the elements, and mesh quality internally, like this. You click, so you can see, and mesh refinement factors, and you can see 0 or 3. You can also increase, but as per the last tutorials it's given that it is too much accurate for the in between 0 to 3, so you can choose. That's why. And hexagonal metal cubes, you can see. Same for the device IVT tab, you can see single electrode, couple electrode. Thermal coupling, you can see electrode, top and bottoms, boundary conditions, voltage, current or current per length, customs, and SIP parameters you can select. Like if you want to variate any value, you can vary. So number of the tabs are given, but in here we are going to simulate series interconnections of the two solar cells. So how we can do? So first you need to move with the DSF geometry files. You can create your own geometry with the liver CAD as well as, and you can also export in here the series interconnected cells that large softwares provide. So first I'm going to show you how you can create one of the series interconnections. Like in the PPT parts we have already show you 1 minute. We need to create this type of geometry. So how we can create, I will show you. First we need to open the lever cats, that's freely tools. You can create any other own geometry. Not only that series interconnection, you can create different geometry. Then you can directly import here, and you can do simulations in here. So first we need to open that LibreCAD. Open LibreCAD geometry tabs. So you can see in my previous video we have already saw some of that structures how we can create. So now we are going to create directly in here that geometry. So P1, P2 and P3. So I will also show on that the last parts how we can set that domains. But first we need to create in here that geometry or structures. So first I'm going to create in here the structures. So you can follow that steps. Vertical 3. You can draw one of the 3 line. You can see that units from here like this millimeters. So we have created 3 vertical lines. Now we are going to create again one of the vertical lines that will be 12 So we need to set again in here the length, snap on the end point and then draw one of that line like this 3 and 12 Now we are again going to create one of the 3 line. You can understand at the last why we are creating this type of geometry. Again give in here the 3 and select vertical as well as snap on the endpoints and click 3. Now you can create in here the 4 and give in here the 4 Now again you can give in here the 3 line 3 and again you can give in here that 12 line and again you can give in here that 3 click on the arrow and you can check in here the total length of this line will be 40 mm. So it is a 40 vertical line and now we are going to create in here the 200 horizontal line. So click on that horizontal and angles and give in here that length 200. Snap point will be selected near the end and then click like this. Same for this side. Now you can see this is the 200 line and 200 Now you can click on this line one by one like this and click on the snaps on entity like this and select near the horizontal as well as angles and then click like this one like this. Now again you will be create same as 40 vertical line one by one vertical line for that 3 start 3 now it will be 12 now again it will be 3 now again it will be 4 now it will be 3 now it will be 12 now it will be 3 like this. So you can see that one of the 40 vertical lines from that side and 200 horizontal lines. So it is one of the rectangles and at the top side you can see it is a P1 top and P1 bottom. Same for it is a P2 and it is a P3 3 top and P3 bottom. So it can be connected as a series and through the resistance you will be separate that points. So you can see that separation in the last software. So you can save that geometry series interconnection made 3 like this and you can save. Now you can open that software again large software and click on that import geometry tab. You can load from your files, click from here, move with the download tabs, apply and OK. Now you can see only line, intersecting line, duplicates line ready for definition. Each of that status are correct We have already discussed in our previous video. You can see points, boundary conditions, and subdomain. Now you can create same as that boundary condition like this. Create boundary conditions. So first you need to select one by one like this and create boundary conditions. It is a each first. I'm follow the same tutorials. One of the each first is created. Now you can select this. Click on the shift button and select. You need to hold your shift buttons and create boundary conditions each second and OK. Again select this line, create boundary conditions 3. We have selected this again and each 4 and click on the OK. So you can see each first, each second, each third and each fourth. Same you can create in here the subdomain as well as like it is a default but you can create by your subdomains like add subdomain P1. OK. Select the P1 and add area to P1 like this and click on the add area subdomain. So you can see it for the P1. Now add subdomain P2. P like this and add area to subdomains for the P2. Click this P2 and add area P2 for this like this and add area subdomains for the P2. P1, P2. Now you can select for the P3. Give the name P3. OK. Add area. Select this and select this. So you can see defaults P1, P2 and P3 and use this geometry as a current project. So now that geometry for the series interconnected cells are imported in here. Now you can change in here units and give one by one each of the parameters. Same you can see. Who want to create in here that geometry by own self. If you want to import existing geometry, you can import from here like this. It is one of the project for the series interconnected cells that's last examples already store some of the project, so you can directly import them. Apply OK and you can see points, boundary conditions and subdomains you can see defaults P1, P2 and P3. I use this geometry as a current project. So you can see that it is the same process you can apply. You can create in here the own geometry and you can directly export from your geometry through the last example. Now you can give in here that units and if you want to create in here the mesh, you can create or give in here that value. Run from the meshing if you want to run in here. After that, you need to provide one by one each of the inputs. Click on the device IVT tabs and you can see you need the default parameter. You need to import here in JV curve. Select this and click on the load and you can select IV perovskite greens. They already inside of this like admin local Fluxim Ag and Lois. It is inside the projects you can see series interconnected solar cell IV perovskite green test. IV curve. You can see IV perovskite and click on that apply and then you can see their graphs like this. Same if you click on this same like this you can import that graphs P1 and P2. You can give in here the ohm and then you can give in here the conductivity for the P2 3.77 1.0 and so you can give like this value and click on the apply. Same you can move with the electrode You can see here the electrode, and now you need to provide in here the seat resistance value. As you can see, it is a default top and bottoms, and P1 top and bottom, and it is a P2 tops and P2 bottoms, same as P3 tops and bottoms, and P3 you can see it is the bottoms. So now you need to provide one by one seat resistance. As first you need to give in here that seat resistance 20 ohm, and for the bottoms you can give 0.265. We are selected in here the example value. It totally depend on the user which type of value they want to select. And P2 tops you can give in here, P1 tops you can give in here the 20, and now you need to give in here that value 1 10 the power 7, because we need to give in here the large seat resistance, because we going to simulate the disconnection of the electrode by the high resistance. Like for the P1 bottoms you can give, and same for the P3 tops you can give. So it will create the disconnections. You can check in here, and now for the P2 tops you can give here the same 20 ohm and 0.265, and in here you can give 0.265. So this value you can provide in here as the stage resistance one by one. Now you need to select in here the boundary conditions. Each first tops and each three bottoms you need to select the voltage for this, and each three bottoms select voltage for this, and all of this current per length. I'm just selecting the examples parameter, so you can see how you can simulate your project. If you want to change something, you can change current per length of this each. They have automatically arranged. If you want to give any the electrical value, you can give. Now you need to provide in here the shift parameters. You can see multiple parameters are available. You can check one by one. Which type of parameters you want to simulate, you can simulate from here. We have already shown in that previous video about this, so you can choose. Each first we are selecting for that voltage. We are going to calculation according to the each first, and we want to simulate their value. So we want to shift from minus 0.2 step to 2.2, and shift step you can consider 0.2, and click in here the OK. If you want to target top as well as bottom or as well as both, so you can select according to your choice. As we have target for the top only, so you can select. And fit or optimizations, how you can extract your parameter, how you can get accurate results, and it is a solver. That solver means which type of convergence you have selected and get the accurate results. So we have selected these settings: simultaneous solver, direct sparse solver, and that matrix. And convergence type you can select absolute residual, normal you can set RMS, and in here you can give 10, and maximum number of iterations you can provide in here the 20. It is just the convergence criteria, and different type of solvers for the non-linear given you can select any one of the method. So like this you can give different parameters one by one. If you move with the thermal coupling type, so you can move with this also. Device type you can see OLED or PV, it will activate according to heat generations or certain with different parameter. And simulation type steady state or AC, so it totally your choice. So now you can run your projects for the series interconnected cells, and then you can get your results. You can see the kernel memory and kernel CPU. Sometime it will be show the error. After the calculations you can see your result. So now you can see that result: total device current, total ohmic losses diagram, bottom ohmic losses diagram, source power diagram, total power diagram. And at the bottom side, you can see that solar cell characterizations, maximum power point, maximum power per area. So you can see diagram per subdomains also available. So one by one, you can check each of the results like this. You can see each of the results one by one. And potential top electrode or the minus 0.2 volt, you can see. So here that results you can see. So which so axis. So different results are available in here with a different potential you can see. And if you want to compare with this result with another one, so please click on the cave diagrams and then click on that total device like this. So you can compare like this with click on the cave diagram. So I hope you got these tutorials and how you can simulate this series interconnected. Not only this type of solar cells, you can calculate any PV modules like or ohmic losses or different solar cell geometry. You can simulate, totally depend on the user which type of structures they want to simulate in here, and they can directly create your geometry in the LiverCAD or any tools, and then you can use the geometry to simulate your required parameter. So now I'm going to end here my tutorials. If you think that tutorials are helpful, so please like, share and subscribe, and anyone who have that query related to this, please ask in the comment box. My email are also given at the end of the video. And who has not seen it my previous video, please check out the playlist. Thank you very much.